Hello, my dear friends. Hope you are doing well in your flying and preparing for the ground subjects. And those who have a license till the time you get a job, keep practicing these ground subjects. They'll be handy for ATPL, they'll be handy for your airline examinations. I've tried to make lessons like this that they are even handy and useful for your ground training instructors. They are welcome to join in. And don't forget to share these videos with your friends. And when I give you certain questions at the end of the lesson, try and do them together. And that's the best way to do the numericals. Right, today we are going to touch a subject called how to plan your descent. And terms like TOD, ROD, etc. Okay, fairly involved subject. And if you are reading it for the first time, don't forget to sit down with your pen, pencil, register and follow me now. First of all, how to calculate top of descent for the destination. That when should I start my descent to reach the destination? Okay, now never ever try to reach overhead and then start orbiting. That will be the simplest method, but sorry, sir, it's not allowed. There is other traffic. And this is an airport, not your girlfriend's house that you start orbiting. Even that is not allowed. There is a certain procedure, and let us say now read what should I do. Now, much before you reach your destination, ask for your permission to descend. Then he'll tell you that report overhead at this altitude. He's been given 4,000 feet. This could be the airfield. In the case of good weather, in bad weather, he could place you at a place from where you can do your instrument approach procedure. This is that point. And now, number one, decide what is your vertical distance to lose. In this case, 20,000 feet to 4,000 feet is 16,000. Step number two, calculate how much time do you require in minutes. Vertical distance divided by rate of descent, which will be given in your aeroplane manual, in this case 800 feet per minute. You realize that you need 20 minutes to descend. Now, when should I start the descent? Find out this horizontal distance, time, 20 minutes into the ground speed per minute. Ground speed divided by 60. Okay. If your ground speed is during descent is 300 per minute will be 5 nautical miles. In 20 minutes, you will need 100 nautical miles to descend. And which true airspeed and which ground speed to use? Find out the mid altitude, 20 plus 4, midway is 12. And use the mid altitude true speed and wind velocity to calculate ground speed. Good job done. Now, if it tells you that this is where you are at this moment, 400 nautical miles to go, okay? 100 nautical miles I have to descend. So I got to travel 300 nautical miles. Travel 300 nautical miles with your cruise ground speed. This distance we calculated with descent ground speed. And find out the time, add it to your time now, and you will know at what time you should commence your descent. And little before that, advise the ATC permission to start descent at such and such time. Good job done. Now, some more types of questions in descent are when you have to descend at a particular angle, which is called approach slope angle. Approach slope is the path on which you will descend in the air. To report over a particular point, which is over the threshold beginning of the runway. During this time, maybe there are clouds, you cannot see the runway. So when you come to this particular place, you will see the runway, and don't descend below decision altitude or minimum descent altitude. Otherwise, if you still can't see the runway, carry out a missed approach. Now, today we are going to concentrate on this particular path. This is the vertical distance which I have to lose during the descent, and this will be the horizontal distance I am going to cover. So start descent from here, and this is the approach slope angle or glide path angle. This is the approach slope, also called glide slope. This angle will be given to you in your instrument approach procedure, and the standard glide path angle is 3 degrees. Now to find out, question will be, he'll ask you what should be my rate of descent. Glide path angle into ground speed by 60, that is per minute, into 100, and this will be rate of descent in feet per minute. And if your glide path angle is standard 3 degree, 3 into ground speed into 100 divided by 60, it will be ground speed multiplied by 5. If your ground speed is 140, descend at 700 feet per minute. Next. So if the glide path angle is not given to you and there is a question in the examination, can you give me the glide path angle? Okay. Then he'll give you, so you have to lose so much distance in, so much vertical distance in this particular distance. So if I have to lose a particular vertical distance in a particular horizontal distance, then vertical distance by horizontal distance into 60. Remember 1 in 60 rule. Okay, then that will be your glide path angle. Or by trigonometry, vertical distance by horizontal distance will be equal to tan theta, and tan inverse will give you this angle. If he tells you this is the distance, what height will I lose? Then apply this. Tan theta is equal to VD by HD, tan this angle. HD is known to you, you can find out VD, and the other way around. There is a concept known as a descent gradient. Descent gradient means how many feet will you lose every 100 feet that you travel. So vertical distance divided by horizontal distance into 100 is known as the descent gradient. If he has given you a descent gradient, and then to find out the gradient, your rate of descent, find out vertical distance you will lose per nautical mile and multiply by ground speed per minute. Then you use this formula and not this formula. And vertical distance lost per nautical mile will be gradient divided by 100 and multiplied by 6080. This will be the distance lost per nautical mile multiplied by ground speed by 60 will give you the rate of descent. This is the formula for glide path angle. Formula for rate of descent when you have the angle given to you, and when your descent gradient given to you, how to find out the rate of descent. And please remember, they will not be exactly be the same. If you calculate by trigonometry and 1 in 60 rule, it will not be the same. And look at the question. If he says use this rule, then use that rule and not your own. Otherwise, your answer may not exactly match. Then you can try both the method. If glide path angle is given, then there are two methods. Gradient is given, then there's only one method. And another question often asked you, what if my ground speed increases or decreases on the final approach? Should I change my rate of descent? Definitely. Remember, rate of descent is proportional to the ground speed. If during descent there was headwind and it becomes less, ground speed will become more, rate of descent will become more. So these are the type of questions you may expect in descent and top of descent numericals. And here are, as usual, the type of numericals you could expect. Different types based on the same concepts which I have explained you. Some are out of the diagram which we studied for the flight plan, when to start descent. Some are given for a particular angle or a particular gradient given to you. Any difficulty, come back to me in the comments that is this question you found it difficult. And of course, before you put your difficulty in the comments, you would like to know the answers. Here are the answers to these 7 questions which I have given you. Hopefully, you have done all correct. If not, try again. If not, try twice again. Mark those questions which you did once or twice wrong. Don't forget or don't ignore them. For all you know, those questions may appear in your examination. Good luck. All the best. I hope you have given a like to the video and subscribe to my channel and share them with your friends. This is S.K. Booty here and Booty Aviation Training, and over for the day. See you again soon.